Hello. In this session, we'll go with alkyl halides. Alkyl halides are the compounds in which halogen is present along with carbon and hydrogen. Alkyl halides. We'll discuss the methods of preparation in this session. From alkenes, you can comfortably prepare. Particularly chlorine and bromine purpose, it is good. Chlorine, bromine we can use. That means RCl and RBr can be prepared much better. Why not Ri? Why not RF? We'll discuss that points also. See, methane, if you take in presence of chlorine and sunlight is required here because the reaction is free radical substitution reaction. It will be forming methyl chloride. If methane is excess, the reaction stops at methyl chloride. These kind of questions will be coming. When methane is excess, the reaction will be stopped at methyl chloride. If chlorine is excess, the reaction will be continued till all the hydrogens are replaced and perchloromethane is formed. Perchloromethane is nothing but carbon tetrachloride. When all hydrogens are replaced, that is called perhalo. This reaction is a free radical substitution reaction. We will discuss the mechanism once. Chlorine bond is undergoing homolytic cleavage in the presence of light. This is step 1. You are getting their chlorine free radicals. This reaction is called chain initiation. Chain initiation reaction, you are getting their free radicals. If you take bromine, same thing, but bromine purpose we generally use here heat. Bromine free radicals are formed. Iodine, if you take, it is easy to form iodine free radicals, and these are too reactive. They form back I2. I dot, that is I free radical, and another I free radical will be giving you I2 back. So these to be used very, very quickly. And one another problem is also there, that also we'll discuss now. So in this way, chain initiation takes place. Next, step 2, chain propagation. Chain propagation means the reaction is going to be continued. Initiation means a neutral molecule is converted into two free radicals. Propagation means a neutral molecule will be attacked by a free radical. It's neutral one, this is free radical, and it is going to give you another free radical and another neutral one. You can say like this is CH3 free radical and hydrogen chlorine, this hydrogen free radical, chlorine free radical are forming HCl. It is neutral one, it is free radical. A neutral molecule, a free radical, gives you another free radical and another neutral molecule, then that step is called propagation. Now this methyl free radical will be attacking on another chlorine molecule. You will be getting their CH3Cl and another chlorine free radical. These steps are repeated. Chain propagation means a neutral, a free radical will be giving you another neutral, another free radical. The steps will be continued. Step 3, chain termination. Termination means ending. So the reaction is going to end now. Initiation means a neutral molecule is converted into two free radicals. Termination means two free radicals join to form a neutral molecule. That is termination. That can be possible in different ways. Two free radicals you take. Any two free radicals you can take, your choice. I am giving you the simplest example. Termination means reaction is stopped here. So this is the mechanism, free radical substitution reaction mechanism. The specialty points are chlorination. If you take one line we mentioned for chlorination, chlorination is more fast, or you say it is highly reactive. Chlorine highly reactive, so less selective. Whereas bromine point of view, if you see bromination, bromine is less reactive, so it is going to be more selective. What is the meaning of this? Look at this reaction. If I take propane, there are two types of carbon atoms. It is primary, this is primary, and this is secondary. Now you are going for chlorination. Chlorine is very fast reacting. Chlorine can come at this place. Chlorine can come at this place also. So this is 1 chloropropane and this is 2 chloropropane. Both are possible. Both are possible. What are the percentages? That also we can calculate. For IIT type of exams, you can expect that question also. We'll go with that one also. If you are taking here bromination, CH3, CH, CH3, Br. This is the major one. You don't expect the minor, that may be less than 1%. So there is no need to write. Bromination means you just write this one, that's enough. Chlorination is very fast, more fast and highly reactive, you can say, less selective. So whatever the places are available, all places it is going to occupy. But bromination, very, very selective. So you can take this reaction also. For example, butane you have. If you want to go for chlorination as well as bromination, light heat. Chlorination means you can take chlorine at this place, chlorine at this place, first place, second place. But bromination, blindly you take secondary or tertiary type. The reactivity order is fluorine is too violently reacting, that's why we don't use fluorine here. Chlorine, then bromine, then iodine. And when you see the reactivity order of alkyl halides, alkanes, sorry, tertiary, then secondary, then primary. This is the reactivity order. So what type of questions can be asked? For your entrance examination, chlorination purpose, tertiary, secondary and primary chances will be 5:3.8:1. I will explain you one question also here, don't worry. Bromination purpose, tertiary is to secondary is to primary is equal to 1682 and 1. You can imagine tertiary, if it is there, clean sweep. Okay, no chance of getting secondary or primary. And if secondary carbons are only available, tertiary is not there, only secondary will come. If only primary carbons are there, then you can expect their primary. Otherwise, if secondary or tertiary are there, that will be the major one. But in case of chlorination, all possibilities will be there. We'll take one example. The first example only we'll take. CH3, CH2, CH3. If you see here, this is primary, it is primary and this is secondary. So number of primary hydrogens are here 3 and here 3. Total 6 primary hydrogens are there. We were discussing primary purpose, that is 1, chances are 1. Secondary 2 hydrogens are there, 2 into the chances will be 3.8, that is equals to 7.6, total is 13.6. What is the meaning of this? The meaning is, if you take this one, chlorination in presence of light, you can get the product like this. Its possibilities are, it is primary possibilities are 6 out of 13.6. 6 by 13.6 into 100. Product chances. Sorry. And for this secondary purpose, chances are 7.6 by 13.6 into 100. In this way, you can answer any question. Most commonly asked question is, you see when you see the different materials, you can check this one. Now there are 4 possibilities you can see. This is primary, it is also primary, this is secondary, this is primary, and this is tertiary. What products are possible in chlorination? See CH2, here I am writing chlorine. This is first product. CH3, CH3, chlorine I am writing here. Second product. CH3CH on secondary. Third product. Again primary is there. Both primaries are same only, but if chlorine is coming here, sorry, I got one chlorine extra here. Because of speed. Now you see, this is primary and this one is also primary. So primary hydrogens are 6, which are present on left side. This is left side. 3 and 3, 6 into 1 is equal to 6. Tertiary hydrogen, only one tertiary hydrogen is there. This is the tertiary hydrogen. 1 into 5 is equal to 5. Secondary hydrogens, there are secondary hydrogens 2. 2 into 3.8, that is equals to 7.6. And again right side primary hydrogen. Right side primary hydrogen is 1 carbon is there, so number of primary hydrogens are 3 into 1 is equal to 3. So total 3 plus 7, 6 plus 5, 21.6. Now you can see the possibilities. Here at this place or this place, that will be same, that is 1 chloro 2 methyl. For this the chances are 6 by 21.6 into 100. For this place, this is tertiary position, so tertiary means 5 by 21.6 into 100. For this place, which is secondary, the chances are 7.6 by 21.6 into 100. And again this place, which is primary, but right side primary only one pass, only 1 carbon, 3 hydrogens are there, so 3 by 21.6 into 100. Like this, generally you need to answer the percentages. But when it comes to bromination, there is no need. If tertiary is there, you give major tertiary only 99.9 also you can write. For secondary 99% you can write, or major simply you can write and leave it. This is for chlorination percentage calculation of the products. You can go back and check if you want. Next, iodination. What is the problem with iodination? In iodination, for example, if you are taking methane and heating with iodine, then CH3I plus HI is formed. The problem with the HI is a strong reducing agent. It is a reducing agent which reduces methyl iodide back into methane. So this reaction will become reversible because of HI. As HI is a strong reducing agent, it can reduce methyl iodide to methane. So to avoid this nonsense, you can say, one very important oxidizing agent is to be used. Generally we use HNO3 or HiO3 are used, which we are calling oxidizing agents. Let us take. What actually happens is, whatever the HI is formed, that HI is reacting with HiO3 to form 3I2 plus 3H2. So whatever the HI is there, all the HI is converted back into I2 because of the oxidation reaction. That oxidizing agent is HNO3 or HiO3. HNO3 or HiO3 are used for this purpose. So it is mandatory. So I am writing here HNO3 or HiO3. Then this reaction can be carried out comfortably. Fluorination cannot be done because fluorine is very strong. Violently it reacts. The reaction takes place even in dark, that is very, very violent. So we don't use fluorination purpose. Further purpose, we go with the Schwarz reaction. Fluorination purpose. Finkelstein reaction is generally used for iodination purpose. Those two reactions also will take now only here. For fluorination, take RCl or RBr, chlorides or bromides, treat them with silver fluoride, or you can treat with SbF3, stibbium fluoride, or you can use here ASF3 also. Hg2F2 also can be used. All these are good. You will be getting their RF. This reaction is called, all naming reactions are very important, so you can note this. Fluorination purpose. Direct fluorination is not good, very violent, so we take indirect method of preparation. First you prepare chlorides or bromides, then treat with AgF, SbF3, ASF3, Hg2F2. All these reactions are substitution reactions. Very comfortably you will be getting there fluorides, and this reaction is called Schwarz reaction. For iodination, as we discussed just now, in that way we can go. Otherwise, RCl can be converted to Ri by using sodium iodide in acetone. It is SN2 reaction, sodium iodide in presence of acetone. This reaction is known as Finkelstein reaction. Finkelstein reaction is one very, very interesting reaction. All naming reactions are important, in that this is very, very special. Finkelstein reaction. Next, we can take from alkenes. Just go for electrophilic addition. See, CH2 double bond CH2. If we add HCl, CH3, CH2, Cl. The question comes when you have given CH3CH double bond CH2, if it is in presence of HCl, CH3 CHCl CH3. This is called Markovnikov's addition. So simple line you can remember, rich becomes richer. What is rich? Hydrogen's rich, you see. In this hydrogen's rich is this one. Don't look at this one. That's a saturated carbon. Unsaturated, it is rich with hydrogen, so hydrogen is going to be added here. That is simple language. But actual definition is, actual statement is, the positive part of the addendum is added to the less substituted carbon. Less substituted carbon means the carbon with more number of hydrogens. And more interesting examples you can see. If you are taking the same compound and you are adding HBr, true, bromine will be added here. But same reaction if you are doing HBr in presence of peroxide, then anti-Markovnikov of addition takes place. Which is also called Karash effect. Also called peroxide effect. Karash effect or peroxide effect are anti-Markovnikov addition. HBr in presence of peroxide. But remember, if you are using the same HCl in presence of peroxide, that will be chlorine here only, no effect. With HCl and HI. So peroxide effect is only for HBr. One very important statement you can remember. Peroxide effect is only for HBr, not for HCl, not for HI. In both those cases, it is not going to be affecting. Questions can be asked like this. If you are using only HBr, double bond will go and bromine is added here. But if you are using same compound HBr in presence of peroxide, anti-Markovnikov addition. This is Markovnikov's, this is anti-Markovnikov's. Very important, HBr in presence of peroxide, you can expect this reaction. Allelic halogenation can also be done in the same way. CH3, CH double bond CH2, when this is treated with chlorine at 500 degrees Celsius. This is again free radical substitution. You will be getting here CH2, CH double bond CH2, chlorine is here. Allyl chloride. One line I forgot. Markovnikov addition is electrophilic addition, but anti-Markovnikov addition is free radical addition. Remember this time, free radical addition it is. So here allylic position, this is allylic carbon, on allylic position chlorine is coming, so this is free radical substitution. Chlorine at high temperatures you can use. Bromine if you want, bromine at high temperature is also fine. Otherwise you can use NBS, N-bromosuccinimide. When you use N-bromosuccinimide, you will be getting here bromine. Allyl bromide. This reaction is again one very special. So questions can be asked like this. If you are using NBS, allylic position you check. If you are having a benzene, allylic position you check. Like this you can expect. These are from alkenes. All these are from alkenes only. First electrophilic addition. These reactions are electrophilic addition reactions. Markovnikov addition, what you are showing is electrophilic addition. Then peroxide is, this particular reaction is free radical addition. When you are going for this is free radical substitution. All these are from alkenes. One very special reaction is from alcohols. From alcohols or OH if you are having, you can use different ways. We'll check all possibilities. First, you can use concentrated HCl anhydrous ZnCl2. RCl is formed. This reaction is called Gross reaction, or you say Gross process, and this reagent is called Lucas reagent. The specialty of this is it's a test for primary, secondary and tertiary alkyl halides. What is the special test? Tertiary alkyl halides, if you are having the turbidity, the reaction takes place immediately without any time lag. Just you add it, you will be getting the turbidity. We mention here turbidity. You can consider like precipitate. If you are using secondary alkyl halides, the turbidity is formed after 5 minutes. Few minutes, you can say 5 minutes turbidity is formed. Primary alkyl halides, turbidity is formed after heating. This is test for primary, secondary and tertiary alcohols. Primary alcohols, secondary alcohols and tertiary alcohols. When you are using with Lucas reagent, you can say easily. I mentioned all external tertiary alkyl halide is formed immediately. See here. This X, what I was writing is formation. I will write now ROH, OH, OH, so that you are getting there tertiary RX, secondary RX and primary RX. No confusion. Lucas reagent is concentrated HCl anhydrous ZnCl2. You can expect these kind of questions in your exam, direct questions. Otherwise, you can use SOCl2 in ether, or you can use PCl5, or you can use PCl3. PCl5, PCl3, the reaction will be slightly different. So we'll take those reactions separately because the byproducts are important here. See what happens here? RCl plus alkyl halide SO2 plus HCl. SO2 is a gas, HCl is again a gas. So these can be removed easily. That's why formation of RCl is best in this method because the byproducts are gases and you'll be getting the purest form of this. PCl5, if you use RCl plus POCl3 is formed. But when you are using PCl3, 3 moles of RCl is formed and H3PO3 is formed. So these byproducts are generally asked in examination. In case of PCl3, you are getting the H3PO3. In case of PCl5, you are getting the POCl3. If I am not wrong, you can see this in the preparation of H3PO3 also in organic chemistry. So from alcohols, by using concentrated HCl anhydrous ZnCl2, we can use SOCl2 ether. SOCl2 pyridine also we can use. SOCl2 pyridine reaction is Darjan's reaction. PCl5 you can use PCl5, PCl3 both you can use, or PBr3 if you are using, you will be getting their bromine. If not, you can use P plus Br2. PA3 also you can use, or you can use P plus I2. If you use this, you will be getting their bromides. If you are using this, you will be getting their iodides. From alcohols, very special reactions. We will discuss more about this in alcohols category. But if any kind of questions are there, we will discuss those questions in this class only. Next, one very special reaction is there, that is Hansidical reaction. Hansidical reaction. In Hansidical reaction, silver salt of acid react with chlorine or bromine in the presence of CCl4 to give alkyl chlorides or alkyl bromides. Silver salt RCOOAg with chlorine in the presence of CCl4 when you are heating RCl plus CO2 plus AgCl. If you are using RCOAG plus bromine in presence of CCl4, RBr plus CO2 plus AgBr. This reaction mechanism is interesting. We'll have a look at the mechanism. RC double bond O minus Ag plus silver salt of carboxylic acid. And you are using their bromine. Ag plus Br minus will go, and it is forming RC double bond O along with bromine, and one AgBr is out. RCOOBr, look at this carefully. There is oxygen bromine bond which is cleaving like fish hook cleavage, and it is giving you RC double bond O dot, and Br free radical is formed. This is again giving you R dot plus CO2. How this is happening? RC double bond O dot na. This electron is coming here, this electron is coming here, this electron is going out. So you will be getting there CO2 and R dot. So R dot is formed here. This R dot is going to attack on next molecule. Next molecule, like this I am writing here, you see. BrOC double bond O R. This bond is formed between them, which is going to form RC double bond O dot plus RBr. This is the mechanism. Silver salt of carboxylic acid when treated with bromine and chlorine. In this reaction, bromine gives a very good yield. Bromine preparation, bromides preparation purpose, this is a wonderful method. And then if you are taking primary, alkyl halides better than secondary, better than tertiary. Tertiary, what you can say, alkyl halides preparation. Because if you want to go for primary, there is no problem. If you want to go for tertiary, there in case of tertiary, elimination is favored. I will give you that reaction also now. Look at this. What actually happens is, for example, we are having CH3, CH3, CH. This is tertiary carbon, about what we are saying. This is COOAG. When you are treating with the bromine, CCl4 heating, CH3, 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 bromine. This is what you are expecting. But actually what's happening is, it is not going to get, you won't get this one, you will be getting here alkene is formed. So it should not be used for this. And for iodination purpose also we should not use, because it gives you ester. And this reaction is very, very special. It has a special name also. Binbaum-Simonini reaction. Binbaum-Simonini reaction. What happens is, RCOOAG, when you are treating with I2, iodine, RCOOR, ester is formed. Instead of getting 2 AgI, instead of getting Ri, you are getting the ester. That's why this reaction is very special. In this method, bromides and chlorides can be comfortably prepared, not this. Not for iodine, not for chlorine. Chlorine purpose, Schwarz reaction. Iodine purpose, Finkelstein reaction. or from alkanes you can prepare, but HNO3 or HIO3 is mandatory. Birnbaum Simon reaction is good for bromides. And some other examples, if you want, you can check like this. If you are having benzene with CH2COOH, first step you are treating with silver oxide, then water, so that it will become CH2COOH. Then you are using Cl2CCl4, right? That COO part is removed and you will be getting there correct CH2Cl. This part is replaced by this one. If it is given like simply COOH, AgNO3 or Ag2O, first step you are using, then bromine in presence of CCl4 if you are using. If you are using chlorine in presence of CCl4 in presence of bromine, you will be getting there chlorine. But we should not use iodine. That is the first point. The yield of halides is primary is best, secondary best, then primary, then secondary, then okay na yield purpose. Bromine and chlorine yield purpose, bromine is better. Iodine will give you esters. That is one very special point. These are few important methods of preparation from alkanes, from alkenes, from alcohols, and from acid salts. These four methods we were discussing along with the Finkelstein reaction, Schwarz reaction. Okay, so you just go with all this. Any doubts you can ask me anytime. Thank you.